This is Mr. Kanaar from Saginaw High, and we're here for another episode. This time we're going to go over Chapter 7, Section number 5. We're going to be talking about radicals today. We're going to be looking at roots and how to solve roots. And I just kind of want to show the homework problems that we did in class. We did 1 through 7. Those ones were simple. And then 11 through 16 in our textbook. They were not too hard. And then 17 through 25, there's some tricky stuff there, so I kind of want to go over it. Talks about how to take something that's in an exponential form and transition it into a radical form. So again, our homework assignment was page 450, 1 through 7, 11 through 25, in case you missed class. Remember, your homework isn't worth a lot of points. It's only worth about 20-25% of your actual grade. That's why I'm going through each one. I want to make sure that you understand what you're doing. So the first one that we did is the 6th root of 64. So you have to ask yourself the question, what number multiplied by itself 6 times equals 64? And I kind of spread it out 2 there. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and times 2 is 64. And you can see that you use 2 6 times. So therefore I can say that the 6th root of 64 equals 2. And that was the type of methodology that they wanted you to kind of see, or kind of spread out to see how to solve this problem. The next one is the 4th root of 81, and you could see that if I multiply 3 times 3, that's 2 3s, or 3 squared, that equals 9, times 3 more is 27, and times 3 more is 81. And therefore I can say that the 4th root of 81 is 3. And then down here on number 3, it gets a little bit more complex. You have the cube root of 125, then to the 4th power. So the first thing I have to do is figure out what number that I can multiply 3 times by itself will equal 125. And I demonstrated 5 times 5 times 5 equals 125. So I can say that the cube root of 125 is 5. Then I have to multiply the 5 to the 4th power, which is 5 times 5 times 5 times 5, which is 625, and your answer there, therefore you can say that the cube root of 125 to the 4th power is 625. Then when you come down, the next part is asking to either write it in an exponential form or write it in a radical form. So number 4, you start out with the square root of x. I rewrote it with the 2 power, or the 2 root, I should say, for the square root, so you can kind of see that. And then I'm going to make that x to the 1/2 power. That's equivalent to the square root of x. And then the next one is the other way around. I start with an exponential form, which is c to the 5th power. And I know that because the root is in the denominator, that is going to be 5 root, okay, to the c. So the 5th root of c, that would be your answer. Remember, the 1, which is in the numerator, is the power. But we don't have to write 1 on the outside because any number is just itself. So down here I have another one that's in an exponential form. And I see that I have 2 over 3, which means the 2nd power, but the cube root. Now, the first thing I want to do is I want to look at the roots. So I'm going to separate the constant and the variable because it's in parentheses. Now, if it wasn't in parentheses, I wouldn't have to do that. But because it's in parentheses, I have to make sure that the 2 over 3 is to each one. So I have 8 2 over 3 power and 8 2 over 3 power. And then I write out the cube root of 8 to the 2nd power and the cube root of d to the 2nd power. Now I'm going to figure out what exactly is the cube root of 8, and that is 2. I move over here. So I have to go 2 squared, but I can keep the variable by itself, which is the cube root of d to the 2nd power, or squared. And my final answer, because I square the 2, see how that's a square there, that becomes 4, and then I keep my variable the same, which is the cube root of d to the 2nd power. Okay, number 7 is similar, except we're going to the 4th root. And this is where we have the radical first. And I can separate the 4th root of 16 and the 4th root of y cubed. I can separate those because of the cumulative property of multiplication. And I see that a number multiplied 4 times by itself to equal 16 will be 2. 2 times 2 is 4, 2 times 4 is 8, and 2 times 8 is 16. And then I'm going to write the y value in an exponential form. So I'm going to take the fourth root, which is in the denominator, to the third power. And the power is going to be in the numerator, which is the top part of the fraction. So that's going to be 3 over 4. Now, you had a series of very easy ones. You guys could just did them in a calculator. What's the square root of 9? What's the fifth root of 1? What's the fourth root of 625? What's the square root of 81? And what is the cube root of 216? And what is the fourth root of 81? And some of them were already done in your problems. Let me give you a huge overview of the first page I have here. That way, if you want to kind of freeze it or whatever, you can kind of look at what I did. And then I came over here and we started at 17 and I kind of labeled where it goes. You see that the second is the power and the 3 is the root. So I'm going to rewrite it in a radical form, take an exponential to radical, which is a cube root of a to the second power. Now in 18, I start off and I see that 64b is in parentheses. So again, I'm going to have to put the power in the constant, which is 64, meaning it cannot change, and b is in the variable. So I'm going to have the 3/4 power, 64 to the 3/4 power, and b to the 3/4 power. And I end up getting 4 root 64 cubed. So, and then I also multiply that by the square root of 4. Because if you look at my factors, sorry I had to pause here, guys. I was looking at something. If you look at my factors of 64, I see that 1 in 64, 2 times 32, and 4 times 16. This is the fourth root of 16 is 2 times 2 times 2 times 2, which equals 16. So I had to break that up because the fourth root of 64 doesn't exist, but I wanted to find one that did exist to simplify the problem. So I had the fourth root of 4 and times the fourth root of 64. And when I multiply those together, that equals the fourth root of 64. So I ended up getting the fourth root of 64 to the third power, or I'm sorry, the fourth root of 16 to the third power, and the fourth root of 4 to the third power, and the fourth root of b to the third power. And I ended up simplifying that. I know that the fourth root of 16 is 2, and that's 2 to the third power. And then I ended up putting the fourth root of 4b together because both of them were to the third power. And I ultimately got 8 to the fourth root of 4b cubed. And the 4b is in parentheses. And I know that one's a little tricky, so I want to make sure you see that. Now, if you look at 19, they do not have it in parentheses. So you only find to change the exponential form from 25x to the 1/2, I'm going to have 25 times the square root of x. Or what I can do is I can just write 25 and then without the 2 on the outside there, you see the difference, I think you guys do, is the square root of x. Then on z, all I'm going to do is take the denominator, make it the root, and then I'm going to take the numerator and make it the power, and I'm going to get the fourth root of z to the third power. And then on 21 there, they had it in parentheses, so I had to make the square root of each, the constant and the variable. So I'm going to get 5 to the square of x, square root of x, I should say. And then on this one too, again, these were not in parentheses, so 27 stays by itself, but I get a cube root of a to the second power. And then on 23 again is similar to the one that we did at 17. I had to divide 98 because there's no such thing as a square root of 98. And you can see that I realized that 2 times 49 is a perfect square. So I end up, I'm going to have 7, because the square root of 49 is 7, to the square root of 2d. Okay, and that's how I solved that. I divided the two radical forms separate, which is the square root of 2 times the square root of 49 would equal the square root of 98. You can see that I wrote that in there. And then 24, all I did was I took the fourth root of b because it wasn't in parentheses. And then if you look at 25 here, I'm running out of time, I factored that again. I had the cube, I found the cube root would be 8, and this other square root would be 3. And I ended up getting 4 to the square root of 9c squared.